Welcome to Algebra 2. This is our unit on graphing functions, and today we are going to be talking about solving systems of equations by graphing. Okay? So we solved systems of equations algebraically by doing elimination or substitution during the first unit. Today we will be graphing. So what we're going to need to do is we just need to graph both of these lines. So we want them both in slope-intercept form. So this top equation, we're going to have to subtract that 3x over to the other side. So we would have y equals negative 3x plus 6. Second equation is already set for us of y equals 3. So if I were to graph y equals negative 3x plus 6, my y-intercept is at 6. And then I have a slope of down 3 over 1. I'm going to encourage you to put this slope across the entire graph. And that way you can clearly see where they intersect. And then you connect those points using a straight edge or a ruler, and you get a line that should look better than the line I just drew. Second equation, y equals 3. There's only a y equals, which means we only have a y-intercept at 3. And this goes horizontal, so we draw that horizontal line. And then we identify where those two lines intersect, and they intersect right here. And then we just name that point of intersection, 1, 3. So the solution to this system would be 1, 3. Okay, second problem. Once again, we're going to take a look at these two equations. We need them both in slope-intercept form. So this top one here, I've got to move that 3x over first. So I'm going to have 2y equals negative 3x plus 2. And then to get the y alone, I'd have to divide it all by 2. So I'd have y equals negative 3/2 x plus 1. So I can now graph that line. My y-intercept is 1. I have a slope of down 3 over 2. And once again, I'm going to take that slope and extend it across the entire graph. I will take a straight edge or a ruler and connect those together. There's my first graph. Second line. My second line here was already in slope-intercept form. Y equals negative 3/2 x minus 3. Start at my slope at my y-intercept of negative 3. And now I graph my slope of down 3 over 2. And once again, I'm going to take that slope and I'm going to make sure I extend it across my entire graph. I will now connect all those values together with my line, and I will look to see where they intersect. Now in this particular case, these two lines are not intersecting. These are parallel. They never will intersect, so this is an example of no solution. One other type of problem you could have is you could graph a line, and then when you go to graph the second line, you notice that the second line is right on top of the first line. If that happens, that's your example of infinitely many solutions, because your two equations are really describing just one line. We can also solve systems of inequalities by graphing, and it's really doing the same idea as what we just were talking about. So here's our two equations. Y is greater than negative 2x plus 4, and y is less than or equal to x minus 2. We want to make sure they're both in slope-intercept form, which they are. So if y is greater than negative 2x plus 4, that has a y-intercept of 4, a slope of negative 2, so down 2 over 1, I will extend that slope across the entire graph. This is only less than, so this you connect with a dashed line. Okay, there's graph 1. Second equation, y is less than or equal to x minus 2. Y-intercept of minus 2, slope of 1. So I'll go up 1 over 1 across the entire graph. Now you take those points using a straight edge and connect them. And your line should look much better than mine because you can actually use a ruler. And now we deal with the inequalities. So this first graph said y was greater than. So our first equation, cross the y-axis right here. The values that are greater than are on this side. So that means from the dashed line, everything on this side would be a solution. Okay? Now we do the same idea with our second equation. less than or equal to. Well, here's our second graph. Less than or equal to crosses the y line right there. Less than or equal to is everything down here. So everything over on this side of the line would be shaded. Now we want the system solved, so it is only where these two shaded regions intersect, which you can see is this section. So over here is where they intersect. So that's the area that you are going to shade in darker. It is perfectly acceptable to leave those two areas lightly shaded. So you may also go through and erase them if you wish to. But as long as you have lightly marked them in, it's fine to just leave them there. Let's do another example. Y is greater than x plus 1, and absolute value of y is less than or equal to 3. First one's already in slope intercept. So our intercept is 1. Our slope is 1, so up 1 over 1. We'll take that across the entire graph. And we are only greater than, there's no equal to, so that means our line is a dashed line here. And some of you might find this even beneficial to, at this point in time, finish graphing this line by saying greater than. So here's where we cross the y. So greater than is this way. So I'm just going to put a couple marks to show that we'd be on that side of the line. Okay. Next equation is the absolute value of y is less than or equal to 3. So remember, absolute values, you get two equations. So y is less than or equal to 3. Negative y is less than or equal to 3. So divide this by negative 1. So we get y is greater than or equal to 3. Negative 3. So we have y is less than or equal to positive 3, and y is greater than or equal to negative 3. Those both only have a y-intercept. So we have a y-intercept at 3. Solid line because it's less than or equal to. And a y-intercept at negative 3. Solid line and horizontal because it's greater than or equal to. Now if we're less than or equal to 3 and greater than or equal to negative 3, that tells me that I am shaded in between these two sections. And notice where the overlap happens is right here in this area. So that would be the area that you would shade in darker. So that's solving systems of inequalities by graphing.